I'm Junwei Liang, and I'm going to present our video event reconstruction and analysis system for shooter localization using social media videos. This is a joint work with Professor Jay Aronson and Professor Alexander Hoffman. This is the overview of my presentation. I'll first describe what the problem is and then provide some details of our shooter localization system with human verification. So in this system, we tackle the problem of mass shootings. There have been over 2,000 mass shootings since 2013, roughly one per day. And these attacks usually happen in events with a lot of people. So to help first responder and the authorities, shooter localization system is needed, and many places does not have expensive pre-installed sensor systems like the shot spotter. Our system utilizes social media videos available in these events to effectively locate the shooter. So first is video synchronization. So remember I mentioned we work on videos from social media. So these videos usually don't have any metadata like GPS and time. So to localize the shooter, we need to put all relevant video in the global timeline first. So this is a screenshot of our system interface. So by combining automatic video synchronization and manual verification from our previous system, we are able to reconstruct the timeline of Euromaidan protests. So here we use Euromaidan protests as a actual example for our system. So you can see here there are 7 videos, and this is the global timeline. Each color bar means the length of the video. So in the next slide, you should hear some sound. So you get the idea. So we have this kind of videos synchronized, and then we apply our gunshot detection and classification system. So given the video, our system can temporarily localize the video segments that contain one or more gunshots. So this could reduce significant manual labor time when the videos are hours long. So this is a screenshot of our interface. On the left here, you can see the x-axis is the video time. And you can see the probability graph of whether it contained a gunshot during that time. And these peaks are detected gunshots. And on the right, you can see here we have a gunshot type, gun type classification results. Here is a M4. And this is a gunshot detection classification results. I should warn that the video might be graphic. And you can see our system can also predict the count the gunshot, and then also the type of the gun that was used. And after we have detected the gunshot and synchronized all the videos, we can use this kind of information to estimate the shooter location. So for estimating shooter location, we first estimate the distance from the shooter to the camera. Some background on the physics here. We hear 2 sounds for supersonic bullets. The 2 sounds are shockwave sound and the muzzle blast sound. You can see here in this example, when the bullet exits the rifle, the sound trailing the bullet would be the shockwave sound, and then the sound coming from the muzzle of the rifle would be the muzzle blast sound. So when you reach the camera, you can hear 2 sounds. And shooter distance to the camera can be estimated based on this kind of time difference between the 2 sounds. For more mathematical details, you can look at our technical report. And we built a system interface for human verification. So in this graph, you can see this is a audio spectrogram. User can mark the time of shockwave and muzzle blast sound with the aid of automatic gunshot detection and this graphical interface. You can see this clear two peak. The first one is the shockwave sound, and the second one would be the muzzle blast sound. So after we have these two sounds marked in the video, so we have the time difference, right? Based on some mathematical computation, as in the paper, we can have an estimation of the distance between the shooter and the camera. In this example, in the Euromaidan protest, it is happened near the Hotel Ukraine, and the pink here is the camera location. So we can see a donut-shaped estimation, and the red location would be the more likely location of the shooter. And the reason that there's a area that's possible because the bullet speed is not is a range. We need to put in the bullet speed range, and the inner circle means the bullet speed is faster, and the outer circle means the bullet speed is slower. So after we have the distance, we want to also have the direction estimation. To estimate the direction of the shooter, we need a pair of synchronized videos, both recording the muzzle blast sound of the gunshot, and we also need accurate camera location. And then we can utilize the time difference of the arrival of the muzzle blast sound at the two cameras. So this is what we can get from the direction estimation. You can see there's a pair of videos. One is from the hotel, one is on the ground. You can see there's this hyperbola lines, and the green line would be the most likely shooter location. So by combining the distance and direction estimation, we can get the shooter location. The overlapping area is the most likely location of the shooter. This is a system interface demonstration. So first we synchronize the videos. And then we need to put in the gun type that is used and the bullet speed range. And then the next step would be to, as I mentioned before, use the interface to mark the two sounds from supersonic bullet, the muzzle blast sound and the shockwave sound. Yeah, as we can hear that there are two sounds here for a single gunshot. That would be the shockwave sound and the muzzle blast sound. And after we have all this information and also put the camera on the map, we can utilize our interface that utilize the Google Street View and estimate the shooter location. You can see here, this is the distance estimation. You can see for 3 cameras, we have 3 donuts, and the overlapping area would be the most likely location. And then for direction estimation, you can see the 3 green lines overlap at the bottom of the image. And with distance estimation here, this would be the most likely location of the shooter. And based on the report from the Euromaidan protest, that's actually the location. And we also use our system for the Las Vegas shooting events. And here on the bottom left, you can see the Mandalay Bay Hotel. And this is the pair of cameras from the music festival. And our system also correctly estimate the location.
Yeah, thank you, Junwei.
Yep.
This time is almost up. Do you want to conclude the talk?
Yeah, so that's it. So thank you. We have verified our system with the Las Vegas shooting and Euromaidan protests. Our system is also reported by the media. It's accepted by ACM Multimedia and Best Demo Award. This is the link to the project site. And we also have another open source work for social good that is social distance early warning system. You can check it out. That's it. Thanks.
Cool. Yeah, very interesting and very cool work. Any questions from the audience? Okay, so one question I have is, like you mentioned this Las Vegas gun shooting as an example, but I also know that in many cases, there are geotagging when people post saying that, oh, I'm actually in this hotel, I saw that there's a gunshot here. So in those cases, it becomes like, it seems that you can just directly use those informations to identify where the shooter is. Is the benefit of this system that you develop being that you may be able to do better than those kind of geolocating, or is it can be used to find the location quickly or faster than what they post there?
So to be able to localize the shooter, you need to synchronize video and also have the geotag of the videos, and then you have all this triangulation computation that you need to do. So having the GPS location is just the second step, and then after have the GPS, we also need to compute based on the sound of the gunshot.
I see. Because what I was thinking is that if there are some information saying that, oh, this is probably from this particular hotel, then you can do the inference in the reverse fashion. Like if the gunshot is indeed here, does it match all we have observed? Then it probably is. It could be easier. I don't know. It could be easier than just to do this triangulation.
Yes, definitely. If you have if the video already have geotags, that would help improve the accuracy a lot.
Yeah.
Okay.
Cool. Yeah. Thanks a lot.